Hello and welcome to one of these more theoretical, shall we say, screencasts or pencasts as the case may be, where I want to talk about my view of an ideal electric bike. Or certainly there are many ideals and people have different kind of wishes, but in my mind the electric bike is by definition a universal bike, meaning that there is no like EMTB or e-touring. There is just a bike, and that bike can fulfill all the roles at the same time. And certainly the I made several videos on the Reese Miller Delight. That's to me something of a universal bike, shall we say. So we're going to talk about all the different parts of the bike and how I think they can all converge to some degree into a single model that would be kind of the best that you can realistically get. So what is an ideal bike for me? Well, first of all, an ideal bike is by definition dual suspension. There is really no reason in the time of riding, which is 2018, there is no reason to go for a hardtail or let alone a rigid bike. You really want dual suspension, and there is no reason why you can't have it kind of anywhere. I'm not very good at drawing, so this is my rendition of the dual suspension bike. So regarding dual suspension, first of all, we know that there is no problem in making dual suspension bikes. It's only a bit more complicated because you have some sort of rear bracket and there are different rear suspension systems. But the upside of all of this is you're not really losing much. So what I like about Reese and Miller specifically is they attach a rack. They attach a rack which looks kind of like this directly onto a dual suspension bike, and there is no problem. And I've been using it for a year now and I'm enjoying it. I have these huge bags that kind of go like this on both sides, and I can put something on top of the rack. I've had so the carrying capacity, at least in the Reese Miller case, is 20 kilograms. But really, if you look at kind of mechanical bikes which have a hardtail, like the Salsa Black Bottle, which is a cargo bike that I have, or a touring bike, shall we say, it supposedly carries 50 kilograms, which is quite a lot. It's almost enough to carry an adult. So personally, I think that by strengthening the way in which the rack is done, you can maybe increase this. I certainly think that 20 kilograms is very good generally, and the only downside to having 20 kilos is that all of this weight is concentrated in the rear. So we can kind of draw, I don't know, a force diagram. Maybe let me grab a sufficiently light color here, and we can, well, let's have them in red because forces are unpleasant. So there is a downward force of I don't know how many kilos, and then of course there is the weight of the rider here, and then there is the rear hub, which also has a smaller downward force, but at least it's very concentrated around this because that's where the rear hub would typically go. So essentially there is no real issue with loading the bike a little bit. I mean, if you are okay with having 20 kilos, then you can easily have, let's say, a battery of I don't know, 2 kilowatt hours, equivalent in lithium ion, not live PO4, but lithium ion, just ordinary. You can have maybe like a 7 kilo battery or something to that effect. Yeah, it's heavy. I'm not arguing that, but it's that good. So dual suspension. Now, the amount of travel that you typically get on dual suspension electric bikes is minimal. So typically this element, when we're talking about the kind of touring bikes, is 6.5 by 1.5 if you prefer inches, or 165 by 38, I believe, is the metric measurement. So 165 millimeters total distance between the I think they're called lugs or something, the holes that attach to the frame, and then 38 is the travel. So the travel isn't really that much, but I find that it's sufficient, basically, unless you weigh 100 kilograms, in which case You just have to increase the pressure, so to speak. So in terms of the front fork, this is where things get really interesting, because we have the DIY people as well as the kind of ordinary bike manufacturers. So typically it would actually branch something like this. So if you're a DIY crowd, then you will have almost by definition 203 millimeters downhill fork. So the DIY people go for downhill forks, and those moped looking electric bikes, they typically have many of them are inverted. So you have things like DVO Emerald if people are wealthy, and if they're not, then they get cheaper, nastier forks. This is where things like Fox 40 come into play, and similar. So Fox 40, DVO Emerald. Then on the practical side of things, if you look at, let's say, what you get from Reese & Miller, you get about 120 millimeters travel. And Reese & Miller can give you like a Fox 34 performance, or Suntour Ion. And this middle where you would have maybe 150, 160 is the supposed EMTB crowd. So electric mountain bike, specifically for kind of, and there are obviously electric downhill bikes from High Bike, also a very niche model. Generally, I find that 120 millimeters is very sufficient. By the way, if we think about outside the world of electric bikes, then fat bikes, if you think about the RockShox Bluto or Manitou Mastodon, they typically have either 100 or 120 millimeter travel. And personally, I find that 120 mil combined with, let's say, a fatter wheel gives you so much suspension that you don't really need anymore, unless you're doing really, really mountainous stuff. So the EMTB crowd, I would say, is, well, there always be EMTB specific bikes, and those are not the kind of bikes where you have dual battery and whatnot. Those are simpler, shall we say. Okay, so coming back to kind of the ideal frame and motor and whatnot, I'm actually going to talk about a mixture of different systems, because no single manufacturer makes an ideal kind of system. So first of all, let's talk about batteries. Now, I, as a user of dual battery, I really like the in-tube or the down-tube and top-tube dual battery systems. That's where you have integrated batteries into the top and bottom of the frame. So these integrated batteries, I mean, at the moment, they're only offered by Bosch. And the best thing that you can do is 500 watt-hours from batteries. So if you combine them together, you get 1 kilowatt hour, which only seems a lot because the batteries by proprietary manufacturers are so expensive. That's not to say that the same situation is you have in the DIY space, because in the DIY space, you're not going to impress anyone with 1 kilowatt hours. People make much larger batteries anyway, and you also have better choice of chemistry on the batteries and whatever. But that's beside the point. I would say 1 kilowatt hour is the absolute minimum for a pedal assist bike. So 1 kilowatt hour is what this translates to in practice is if you go slowly, you'll get about 200 kilometers. If you go quickly, if you go in, let's say, the sport mode, you get 100 kilometers. So this is the range, 100 to 200 kilometers, depending on how you travel. Obviously, you can take extra batteries with you. I typically take another, let's say, another 400 watt hour battery with me. But this really, it's up to you how many of those you buy. I would say that it's certainly more difficult to take the power tubes with you than it is to take the ordinary, the kind of cell that we have, which is, the typical. Oh, I seem to have lost an ability to draw all of a sudden. Hold on. Let's see. No. Oh yeah, I've changed the pen type. Let's get back to. There we go. Okay. So yeah, it's really, you can have extra batteries with you if you travel, but this down tube concept, and that's if you look at the supercharger, the Reese Miller supercharger is the only bike I've seen that does uh, two parallel in-tube batteries, and it does it really well. Obviously, there's a question of how it plays with the rear shock, because it attaches to, well, it's a specific frame design on the Delight. Not something we're going to go into. I'm going to assume that it is possible to engineer such a frame. So personally, I think on the rear and on the front, the kind of measurements that we have, so 6.5 by 1.5 on the rear and front suspension of 120 is perfectly sufficient. And then let's talk about wheels, tires, and all that sort of thing. So obviously, anybody who's ever tried a fat bike knows that a fat bike is just better than an ordinary bike by whatever criteria you pick, basically. So if we're talking about e-bikes, then if we're talking about electric bikes specifically, then fat electric bikes are way better. You get more stability, you get better cornering. It's just better in all the kind of dimensions. And here you have different options. So typical fat bike, a typical kind of canonical fat bike, it has 4.8-inch tires. This is the kind of it used to be, I suppose people started out with 4 inches, but now 4.8 inches seems to be the kind of, what most people want generally, where you get the most choice. So 4.8 is kind of where the fun is at. 4 inches is where you actually get electric bikes nowadays. So, for example, I recently ordered a high bike, fat bike, and that fits 4-inch tires. Maybe 4.4 will go in, but it's a bit iffy. So obviously on the front forks, they all fit very large tires up to 5 inches. So whether we're talking about Bluto or Mastodon, they all fit about they can fit 5-inch tires if that's what you want. Realistically though, we only care about the rear wheel specifically, because the rear wheel is the one that is driven, so it's the one that pushes you out of the snow and whatever. So you basically, and if you look at the tread pattern of the front and the rear tire, whether we're talking about the Maxxis Minion or whether we're talking about the Shirley tires, Shirley, not sure how to. So you have the front tire and the rear tire, and the tread pattern on the front tire is like this, because you want to go forward without somebody moving you to the side. So the front tire is like this, and the rear tire is basically like this, give or take. So essentially the rear tire is horizontal. That's why it has a lot of grip, lots of traction, and the front tire just rolls you forward without having you slip from side to side. And obviously you get studded and ordinary variants of this tire. So all these choices of the different wonderful tires exist in the 4-inch space and the 4.8-inch space. The reason why I'm bringing this up is because I think that if you have ideal conditions, if you have ideal roads, you don't have any snow, you don't have icing over. My personal favorite at the moment is around 3.8 inches, and this is motivated by the fact that you can get a Fox 34 fork for that size, or at least you could in 2018, because they're slowly disappearing. Now, why am I talking about Fox 34? Why is it so important? Well, unfortunately, or maybe fortunately, I don't know, Fox 34 is vastly superior to Bluto and Mastodon and Ren and all the other forks. I'm not sure about the Carbonara, the Leaf Carbonara. That's an interesting fork, a completely different design. But generally, the Fox 34, which I installed with a 3.8-inch tire, so I'm talking from experience here, is vastly superior to anything that I've tried so far. So I would say that generally having 3.8-inch tires is awesome. It's good enough in terms of going through snow and whatever. Now another question is whether you have 26 or 27.5. So generally you have, obviously 4.8 is a 26-inch specific thing. You don't have it in 27.5, but you can have 27.5 by 3.8 or by 4. I have 27.5 by 3.8 tires on a Salsa Black Boro that I mentioned, and they're okay. they're generally okay. Suddenly, the 27.5 3.8, it fits barely into a Fox 34. The 26 3.8 fits comfortably into a Fox 34. Well, comfortably, I'm saying you got about on the sides of the tire, you got about maybe 4 millimeters on top and the bottom. And on the top, obviously, because it's a 27.5 fork, you have, I don't know, maybe 2 centimeters of space above the tire. So that's very comfortable, like 20 mil. So if I had to sort of pick a size, I would say 26 by 3.8, something to that effect. That's more than sufficient for me. Going lower, going to 24 would be reasonable, but then again, this alters the way that frames and forks are designed nowadays, and you're simply not going to be able to find the components which actually make this whole thing comfortable. So in terms of, let's talk about the motor and the drivetrain. So I'm going to try and move this to the side a bit. So in terms of the motor, the thing that drives everything together, I would say that my choice at the moment, if I could choose anything, is Yamaha. So you're probably wondering, well, why not go for the ultra powerful, like the Bafang Ultra or something to that effect? Well, in practice, in the real world, I find that the motors which are sold right now, like the Bosch and the Yamaha and so on, are powerful enough for the vast majority of the situations you run into. Like you're in knee deep in snow and you switch to turbo and you jump out of that snow. There is no problem. Now I know that you can get, extremely powerful motors from the likes of Bafang, but personally Yamaha is more pleasant than Bosch because unlike Bosch, Yamaha can be pedaled without motor assistance. In the case of Bosch, it's extremely painful. It's very unpleasant, extremely unpleasant, I would say, to pedal without any kind of motor assistance. So once the battery dies, on Bosch, I had this situation once when I was stuck in the middle of nowhere with a Bosch motor, and it was really unpleasant. Yamaha is better in this regard, not to mention the fact that Yamaha allows you to have two chain rings, not that anybody cares nowadays. Now, the greatest thing about Yamaha is that the battery, the Yamaha batteries, we're sort of going away from this idea of Bosch power tubes, because Yamaha doesn't have dual battery, it doesn't have a system for connecting both of the batteries to the motor at the same time. But Yamaha has something different, which is maybe more relevant to the DIY people among you, and that's the fact that the Yamaha battery protocol has been reversed. So Yamaha also has their own weird-looking batteries, kind of look like this, more stretched out than Bosch. But the thing is, what you can do is at the location where the battery is connected to the motor, there are these three prongs going like this. What you can do is you can buy an adapter, and this is obviously not an official thing, but you can buy an adapter which goes on top of these. So it goes kind of like so. And then you would get kind of wires going like this, schematically. You can essentially connect any 36-volt battery, any battery that you make yourself or that you buy on demand or kind of custom order, and you can connect it to the Yamaha motor and everything will work. So if you want lots of travel, because in Yamaha a single battery is 500 watt-hours maximum. So either you take lots of these batteries with you and you swap them out because there isn't, like I said, no dual battery system, or you build your own battery. And this by itself is quite a challenge to kind of manufacture your own battery, because typically you want the battery to be in the main triangle of the frame. You don't want it towards the rear, because like I said, yes, you can load the rack quite a bit, but if you can't stick it here, you really want to do that. And for that, you need a big triangle. Now, one thing you might have noticed in modern frame design is that typically when you buy a frame nowadays, it goes something like this. there is no like horizontal bar. It goes down, and I think what part of the reason this is done is because for men who accidentally kind of jump off the seat and they land somewhere here, they don't end up hurting themselves so much when the frame goes down like this. Now the downside of this is that the space which you would typically use for a battery is rather limited, because ideally you want to use as much of the space as possible. So my solution to this, which is quite predictable, I think, is to simply extend the width of the front. So if we look at a typical bike from the front, where this might be, let's say this is the handlebar. This is the handlebar, and you would have, the stem and the fork arches, and then the actual frame going like this towards, let's say if the seat is somewhere here. Let's say if the seat is somewhere here, what I would do is I would simply widen the frame somewhere around here. So essentially I would do something like this. And in this regard, what you get is you get a lot more space to basically put the battery in here. So between the two parts, you can stick a huge battery in here and get all the power. Maybe you want to taper it towards the end. Maybe you want to extend it all the way. I don't know. In actual fact, this kind of ties into another idea which I have, is that even though 120 mil travel is perfectly fine for an e-bike, what I would prefer is a dual crown fork. So typically the kind of forks that we're talking about are like this. There is basically a that there is the kind of crown, and then there is the two legs on either side, and they hold the wheel. But for downhill forks, what they do is they just have two vertical kind of bars, and then there is a middle bar here. That's what where the stem goes. So the stem goes about here, and there's like arches on top and the bottom, and this provides more rigidity. Now, like I said, if we're talking about DIY stuff, people typically do put such forks on the bike, but I think they kind of warp the design somewhat. So my idea, if I could choose anything, if I could manufacture anything, I would say make forks which are maybe 120, maybe 150 millimeters of travel, but make them dual crown, so that you can actually get all those extra benefits. And the dual crown fork will tie nicely with this idea that I have here of basically putting more batteries into the actual putting more little 18650 cells into the actual battery, because at the moment, if you look at the way the battery is designed, I think they're kind of, there's a single battery going across, and then there is a stack of them like horizontally and vertically, and it goes like this. I would put two of them, twice the space, and at this location it doesn't really interfere with your legs, because your knees might be right about here maximum, and then everything else can be just adjusted in the following fashion. So perhaps this is where electric bikes should go. Maybe it looks too much like a moped or motorcycle, but I think that ultimately we're going to see some sort of convergence sooner or later between the motors and the between the mopeds and the bicycles, and we're already seeing it in some locations. So coming back to the idea of like what's the ideal motor, for me the Yamaha is ideal with a custom battery. That's everything that I want. In terms of the drivetrain, like what do we want on the rear, personally I think roll-off is the best that we have. I mean, having tried it, I would say roll-off. Maybe Enviola or some of the other hubs are equally good, but roll-off is, it's 14 different speeds, and it's, well, I wouldn't say bomb-proof. It does have issues, mainly issues to do with switching, because the actual gear shift on the roll-off is rather bad, the mechanical gear shift. But in terms of like building a rear wheel, I would say roll-off is the best thing that we can actually get right now. So if you know anything better, then then tell me. But I don't think there are many competitors which do things as well as roll-off does. So next up, the one thing that I kind of neglected is the idea of being heavy duty. and having a cargo bike. So essentially, you just so that you know, just so you have an idea, a cargo bike is a bike that's designed very similarly to an ordinary bike, except that if we take the seat tube to be here, notice the seat tube is like in the middle of the bike. It's not towards the rear wheel. It's kind of in the middle here somewhere. So this is the seat tube. And what happens typically is, so you have the frame going maybe like so. Let me just draw this. This is where the fork would be, which would go down to the wheel. And here what happens is, well, on the hardtail at least, you have just a chunk of space. So here in between the seat tube and the rear triangles, whatever, you just have this. Well, maybe I'm drawing it too big. Maybe the wheel should actually be a bit bigger, but you have a chunk of space here which is kind of unused for anything. And the reason for this chunk of space is so that subsequently when you have a rack, and typically you might want to attach a rack, let's say to this point and this point, so you have a rack which is longer. Notice that this is a longer rack than you typically would be able to afford. So this kind of rack allows you to carry lots of cargo. You can have two kids sitting on there, or you can have a child and a lot of bags of food sitting there, whatever you want. So this concept has to somehow marry the concept of suspension. Dual suspension, because ultimately, like I said, there is no way that I'm going to give up dual suspension on a bike, even if that bike is a cargo bike. So my idea, which is a rather simple idea, was to introduce some sort of suspension which would still hold up a heavy rear rack. So one idea would be, let me just grab the kind of red. One idea would be to make a rack pivot here, and then create a suspension between the axle and the rack, something like this. This is only an idea. Obviously, you need engineers to come up with something which would still allow dual suspension, because essentially what you want is well, I have to now finish this, because essentially somehow you want the whole thing to fold effectively whenever people are, whenever you actually hit a bump. So this is not a not a finished idea of mine. This is just something that I kind of been playing around with as a concept. And well, we'll see. Maybe I'll implement something. Actually, this is part of something even crazier that I'm trying to do, which is a quad, but we'll talk about quads and all the rest of it in a while. So let me continue with discussions of what I would want to have on this sort of bike. Let's just go back here. So front suspension, rear suspension, a rack that's particularly big, because ultimately, I don't think that, I mean, with an electric drive, there is really no I mean, if this chain is particularly long, if this is like a huge chain, like it is on the Black Bottle, which I have, then so what? It's it's just a chain. You can throw it away later and get a new one. It doesn't really, I mean, tandem bicycles and reclined bicycles, they all use very long chains, and there is no particular issue with it. So one thing that I wanted to mention is electrical outputs, because this is one where the current manufacturers have typically done very bad things, or, well, not bad things, but just being insufficient. Like, for example, on a Bosch system, you have a bike computer here, and that bike computer can give 500 milliamp hours of energy, which is ridiculous. What you really need is, if you have some sort of electrical system, whether it's here in the rack or whether it's here in the triangle, I would say that the number of outputs available on the bike should be large. It should be several, because, I mean, imagine, like, for example, I personally use lots of stuff on the bike. I have an action camera, I have a speaker that I want to run, and all sorts of other things. And typically, most of those are 5 volts and 2.1 amps. So that's over 10 watts per unit, and I want several of them. In addition, like if you enjoy good lights, then you have maybe the supernova on the front and maybe even the rear. And this is just something that takes 36-volt direct. So instead of having it routed through the eating Bosch batteries, I would have something that, well, I would connect it to the overall battery and just have it on a switch, because it also has a distance light switch. So I would have two switches, one for on off and one for kind of near light, far light, or distance light. And there's generally never enough. There's never enough electricity, and if you have huge batteries with you, then it's great, because then you have everything that you need, and it's just a good idea generally. So I would have these USB ports. I would have the rear light and the front light as well, and have things like powering your speakers so you can play music at loud volumes, which maybe not okay in the city, but as soon as you go outside the city, it's just it's normal. People do it. All right. So I think I've covered kind of most of the design that I would want to have if it was just an ordinary bike. Because to be honest, I mean, the recent Miller Delight is already pretty good, but I would want fatter tires. I have a fatter tire on the front. I would want one at the back, and that's pretty much it. Once again, if you are living in a very kind of icy area, maybe in Alaska, maybe in Canada, maybe in parts of Russia, then yeah, 4.8 inches should be the standard, and you should take the hit of a weaker fork, shall we say. So most of these forks, they are only guaranteed to operate down to minus 20 degrees Celsius. I don't know what happens below that, because we never typically have those temperatures. Now the Fox fork operates perfectly at minus 20 C, and I have no complaints. When I had the Suntour, it would just freeze at minus 20 C, and I would get motion sickness because it just didn't work as a fork at all, which is very sad. So that is pretty much what my design would be overall if I had to design. Now let's talk about something that's more science fiction-y, and that is the idea of a quad. And this is the idea that there is one thing that this bike, the bike that I've designed here, will never be able to do, and it is the idea is that it would never have stability on ice that's been snowed over. So what typically happens is you have an uneven road. Let's say it's just mud, and it's all uneven, and maybe cars are going through it and stuff. And then you get a layer of ice which goes over it and kind of fixes this unevenness, so that there is there is now like a layer of ice on it, which may or may not mirror the design of the road. And then on top of that, you get a layer of snow. So somewhere up here, you get a layer of snow. You don't really see the ice anymore because it's just all snow like this. Okay, now the problem is that even with spiked tires, when I go over this snow, it keeps throwing me from side to side. So I go on top of this with the front tire, and it kind of throws me in one direction or another. Certainly having fatter tires helps, but it only helps to some degree, and people still struggle even with 4.8 inch tires. So the question is, well, how can we get extra stability out of this? So this is one example where maybe more wheels would be generally relevant. Another thing is on sand, for example. Even though fat bikes generally operate really well on sand, it would be nice if when you dig yourself into the sand, you don't end up sliding to the side with either the front or the rear. So my idea, which is an even crazier idea, is that you should have 4 wheels instead of 2, but not turning it into a car or anything like that. Essentially, the way that I view this is on both the rear and the front. So if you imagine the rear and the front of the bike well, we'll do the front a bit later, but the rear, if you imagine two wheels having their own hubs, kind of lefty hubs, we already have this concept of the lefty fork, a single-sided fork, which perfectly handles a wheel with just one side of attachment, so attached on just one side. So if you imagine these two wheels, which both have their own suspension mechanisms, so they have their own suspension, like so, maybe. Well, I'm just drawing this schematically. So they have independent suspension. When one of these hits something, it doesn't cause the bike to go off to the side because the other one is doing perfectly fine. So this wheel would go up and not to the side, and everything would be okay. So that's on the rear, but you have to have this as an articulating mechanism, because what happens in such systems is when you turn and you lean the bike to the side, so let's say you lean the bike to the right, you also want your wheels to lean as well. So you want your wheels to lean kind of like this, and none of the designs that we have right now accommodate this concept, because typically you have just one wheel, and so if you lean the bike, so here is the bike and here is the wheel of that bike, you lean the bike and you lean the wheel, they're all coaxial, they're all on the same axis anyway, so that's not a problem. But here what would happen is not this. So if you were to do this in my design at the moment, what would happen is you lean the bike like this, and then you end up basically standing on one wheel like so. So here's the ground. It's the ground. You end up standing on one wheel, and the other wheel goes off into the air, and you simply fall. So that's something that we want to avoid. And so these wheels have to be articulating. Now, we already have some designs, including motorbike designs, where this actually has been attempted. The Honda Nikon is such as design, and it's really sophisticated. So essentially, the idea behind a Honda Nikon is that you have an articulating mechanism which goes kind of like this. So if I draw it as these two stanchions, which in turn have kind of one-sided forks with two suspension rods. This is where one wheel would be, and this is where another wheel would be. So now you can sort of take this part and this part, and you can move it up and down, and the wheels would move up and down. But also there is rotation, obviously. So there is a rotation thing, and this is done using another special mechanism that's here on the front, and that's where you would effectively move this bar left and right, thereby providing both the turning as well as the articulation that we want, like the articulation shown here. And this allows us to have a proper kind of four-wheeled vehicle. But this is more of a kind of experimental ideas that I'm thinking about, because even designing an ordinary bicycle frame is already extremely difficult, and I will at some point show some of the designs and schematics that I have in this regard. But that's pretty much all that I wanted to show for now, and I'll expand upon these ideas, so feel free to leave comments. Thanks for checking out this video, and stay tuned for more videos on bikes and thoughts about bikes as well.